Energy policy across the globe has become a staple in recent history, with focuses on the development and implementation of energy conservation to provide a better future for our world and those that reside in it. Amongst important topics regarding energy policy, energy sprawl touches on the expansion of sustainable energy. Multilateral development banks provide the groundwork for funding for projects and reducing economic instability around the world. And finally, the Paris Climate Change Agreement, mentioned throughout Kruger et al. 2017, has created international awareness and goals while providing a framework for future adaptation and policy regarding climate change in the coming decades. To begin, energy sprawl in simple terms is the amount of energy that can be produced in a given amount of space, or the land use footprint of energy development on habitat, biodiversity, and ecosystem services. With an increased demand for renewable energy production, it must be determined at what cost this energy can be produced. In terms of sprawl, that cost is the amount of space required for those demands to be met, compared with energy production and carbon emissions. I was able to find a fun little interactive tool that I actually put a link to that shows the differences between fossil fuel and renewable energy impacts on both CO2 emissions and land conversion. Fossil fuels in this case include oil, coal, and gas, while renewables include wind, solar, biofuels, and hydropower. This is most adequately done using terawatt-hour, or TWH, by square kilometers impacted in most scenarios. A table provided by Traynor et al. 2016 provides a view on the direct footprint of individual energy sectors in comparison with the landscape level impacts to determine which of these is the most efficient. In this case, the higher the landscape impact, the less energy extracted per square kilometer. But as shown in the interactive model, CO2 production is variable based on the source of renewable or non-renewable energy. The direct footprint in this case, as described by Traynor, is the area cleared for use of the energy source. The total area, or the landscape level impact, includes all spacing requirements and land necessary for each. In this case, the greatest energy sprawl is from surface coal at 8.2 square kilometers per terawatt hour and non-renewable energy sources, with wind infrastructure being the most land use efficient source of renewable energy in terms of direct footprint, but also one of the highest landscape level impact sources of energy due to regulations and limitations on the land, second only to biofuels and biomass from crop production. Now on to multilateral development banks. Multilateral development banks, or MDBs, come in two primary forms: Bretton Woods institutions, used for facilitating international cooperation within the global financial system, and regional MDBs, such as the African Development Bank, which are used to develop specific countries or low-income nations. They are financing institutions, which have the goal of providing stable and long-term financing for projects within countries in an attempt to curb economic inequality. Collectively, they are based upon a set of 17 Sustainable Development Goals, which provide sustainable economic development in the pursuit of reducing poverty, providing adequate resources that are maintained properly to the general population, and numerous environmentally oriented goals in the conservation of ecosystems. I was able to find a link directly for multilateral development banks there at the bottom of the page. And along with that, I was able to find this graph or picture showing the different energy projects at a couple different development banks, whether that be the Bretton Institutional or regional. As mentioned earlier with the African Development Bank, that bank specifically has had 75 projects in total, with an acclimated $64,584,648 approved so far. A majority of these projects cover multiple locations, with vested interests in agriculture and management plan development. And one such example that I was able to find is that of the Mauritanium Mining project, which received $989,000 specifically to assist in the implementation of an environmental management system and its corresponding strategic environmental and social management plan. And there I was able to find a picture of Mauritania to give you an idea exactly where it is, and there's multiple mining sources along those different labeled cities as well. The Paris Climate Change Agreement was mentioned in Kruger et al., and I really didn't know a whole lot about it. I knew that we had been withdrawn from it during the Trump presidency, and Biden had brought it back, but I was really interested in it as soon as I was reading about it, so I chose that as my topic. This is one extremely important agreement in terms of global change for energy policy, and it was reached in 2015. To quote the United Nations, the Climate Action Report, climate change is a global emergency that goes beyond nation borders. It is an issue that requires international cooperation and coordinated solutions at all levels, with the central aim of strengthening global response to the threat of climate change through the monitoring of global temperatures, efforts made to limit that increase over time, and to increase countries' abilities to handle climate change impacts through financial stability. Now for the when, the who, and how it's going to affect us. The Paris Agreement encompassed 192 parties, at least as labeled by their site. This includes 191 countries and the European Union. It occurred with a breakthrough on the 12th of December in 2015 at the United Nations Climate Change Conference in Paris, and was formally enacted and entered into force as a legally binding international treaty on the 4th of November in 2016. It provides a guiding framework upon which to build global efforts toward a net zero emissions world, with nationally determined contributions, goals, and commitments being checked every 5 years. As mentioned previously, in 2017, President Trump announced our withdrawal from the Paris Agreement. However, it couldn't be made official until November 4th of 2020. With the changing of presidential office, the U.S. rejoined the agreement under the Biden administration, making official 107 days of us being formally removed from the agreement. This came along with a vow to be carbon neutral by the mid-century. Biden has recently announced a plan to spend $2 trillion over 4 years in an attempt to increase the use of clean energy in transportation, electricity, varying building sectors, and with a general movement away from fossil fuel use. The long-term goals of the Paris Climate Change Agreement are broad, but they are also pinpointed. They want to limit global temperature increase to below 2 degrees Celsius, with efforts to limit below 1.5 degrees, of which both of them have dramatic impacts regardless. They want to communicate and maintain nationally determined contributions, or NDCs, on a 5-year plan. They want to conserve and enhance sinks and reservoirs for greenhouse gases, and be able to adapt as far as resilience and vulnerability to climate change is concerned with varying countries. They also want to do financial building. They want to support these developing countries through education, training, public awareness, and participation. And then finally, their biggest goal, they want to reduce emissions by 45% by 2030. But why does the Paris Agreement seek to reduce the accelerated increase in temperature over the coming decades? First, it must be noted that climate change doesn't occur evenly, but rather it occurs spread out around our planet. Expecting a generic increase between 1.5 and 2 degrees Celsius globally isn't likely. Temperatures increase at different speeds, with warming occurring more so over land than in areas blanketed by oceans. The Paris Agreement states that it has the goal of reducing temperature increase globally by 2 degrees Celsius, with a further goal of less than 1.5 degrees Celsius. Even being lofty goals, they both come with significant impacts on human populations around the globe, as well as biodiversity. At a 1.5 degree increase, you're looking at increases in drought, forest fires, extreme weather conditions, flooding, and invasive species that are bound to occur, with even more dramatic effects occurring at 2 degrees Celsius. This includes a 14% increase in population exposure to heat waves every 5 years at a 1.5 degree increase, compared with a 37% increase at 2 degrees. Because of changes in geographic range by climatic events, there's expected to be a severe reduction in biodiversity in ecosystems. At a 1.5 degree increase, NASA projects that 105,000 species of insects, plants, and vertebrates will become extinct, which includes estimates of 6% of insects, 8% of plants, and 4% of vertebrates. At a 2 degree increase, they project these numbers to at least double, to 18% of insects, 16% of plants, and 8% of vertebrates. This includes pollinator species, such as bees, hoverflies, and blowflies, which maintain terrestrial productivity, but also agricultural crops used for human food. Amongst those increases in temperature, there will be global impacts on human populations concerning disease, illness, mortality, food and water security, and economic impacts. The Paris Agreement looks to mitigate as much of these occurrences as possible, with the understanding that we have done so much damage already. The best we can do right now is to slow the process down. Without this agreement, it is likely that the Earth would continue to spiral at a pace that we cannot keep up with. By establishing the Paris Agreement, a shift towards a net zero emissions world has begun. Thank you for listening, and these are all the references as well as the websites I used for the information that I had today.